All right, the next ANOVA, the General Linear Model 3, is called the factorial ANOVA. So let's talk about what is a factorial ANOVA. What does it mean? So the first question is, we've been running a one-way analysis of variance. So the factorial ANOVA really starts from two-way and beyond. So what is a two-way independent ANOVA? Well, that means we have two independent variables. If it was called three-way, we would have three independent variables. We also have different participants in every condition, so that's why it's independent, right? Dependent would mean same participants, so two-way independent, we have two variables that are using different participants or different conditions. So anytime that we use several independent variables, it's just called a factorial design, because for some reason we call our variables factors. All right, so why are factorial designs good? Well, one thing is very similar to the partial correlation. We can see how these variables interact. So these interactions, we want to be able to say, how does the effect of one independent variable impact the effect of another? Sometimes these are a little bit more interesting than just the main effects themselves. So it's kind of taking that ANCOVA, and here we're adding, instead of a covariate, we're adding multiple independent variables. So a good example of this is the interaction between hangover and lecture topics on sleeping during lectures. So a hangover might have more effect on sleepiness during the statistics lecture than during the history of rock lecture. Okay, so the example that we're going to use for this class is we're going to test the effects of alcohol and gender on the Beer-Gogling effect. For those of you that don't know what the Beer-Gogling effect is, traditionally it's the more alcohol you drink, the more attractive the member of the opposite sex becomes. So alcohol, we can drink no alcohol, 2 pints or 4 pints, and gender is either they're male or female. Our dependent variable is going to be an objective measure of how attractive either the male or the female thought the opposite was after they were drinking the various levels of alcohol. So here's what our data looks like. And essentially the factorial ANOVA is going to be looking at the variance that is the total variance. We break it down just like we did before, the residual, and then the model variance, but now we can break down that model into 3 specific elements. We can look at just the effect of the alcohol, just the effect of the gender, and the effect of alcohol by gender. So maybe you could have females at 4 pints are not the same as males at 4 pints, so that's why your level of interaction would be different. All right, so let's just look at how we run a factorial ANOVA. Again, we're going to have a dependent variable and our 2 fixed factors. So our fixed factors are our independent variables. We're going to want to graph our interactions. And a good way to graph that is just by hitting the plots command. And it's going to show you that we have 2 factors. What do we want to graph? We're going to you can graph the alcohol by gender. So we're going to want to see this interaction down here. We can run some contrast. But again, the contrast are like it was before. We don't have, if you look here, we don't have any contrast for gender because gender only has 2 levels. So we don't need to have a contrast for the main effect. However, for the alcohol, we have more than 2 levels, so we're going to have to do something. So I choose Helmert for this, simply because I want to compare each category against all subsequent categories. So I want to compare no alcohol to all of the remaining categories. Post-hocs are available for factorial ANOVAs. And most of those are exactly the same as we talked about during the regular ANOVA, so you should probably choose 1 for equal variances and 1 for non-equal variances. In the options, we would like to see the means for all three because that's really how we're going to be able to look at how things run. And then here is the output. So for the no alcohol condition, males, no alcohol, chatted up a female who they rated at a scale of about 67 on attractiveness. Females chatted up someone that they thought was at about a 61 on attractiveness scale. So this is going to be useful for interpretation later. If you want to kind of laugh and see what happens as they drink alcohol, what happens to the attractiveness, it is rather funny. Alright, next thing is a homogeneous variances output. We do not have a significant variance, homogeneous variances, so that's good. If it is significant, you might want to try to equal that variance through some type of data transformation. Because we do not want to proceed further. This is not like the regular ANOVA. We don't have really a correction for this. So you're going to have to do something if it's significant. In that data transformation, we've got the three different types you can use, the square root, the reciprocal, and so on. All right, the main ANOVA table that we see here. Let's go ahead and look at, we have two main effects. We have the main effect of gender, and we'll have a main effect of alcohol. All right, the main effect of gender is not significant. So gender did not have an impact all by itself. So this says when you ignore the alcohol level, the gender of the participant did not influence the attractiveness of the date selected. All other things being equal, males and females selected equally attractive dates. Now we cannot say the same thing for alcohol. Whoops, sorry. Alcohol had a significance rating of 0.00. We'll get to that in a minute. Let's look at another interpretation of the gender. So there was a non-significant effect of gender on the attractiveness of the males, of the mates, and the p-value was 0.161. Well, if you look at the plot, the graphs don't look all that different. So that kind of validates the ANOVA table itself. So our ultimate result that we can say there's not a significant main effect of gender on date attractiveness. So that's going to be the exact wording that we're going to want to see in the results of these types of tests. All right, now let's go ahead and look at alcohol. So the main effect of alcohol, like we said before, was significant. So that means that the amount of alcohol consumed significantly affected who the participant chatted with. So overall, when you ignore males and females, the amount of alcohol impacted date selection. I'm going to write that down because that seems to be a critical statement. Just remember what I said. Overall, ignore gender. the amount of alcohol impacts so when you ignore gender, the amount of alcohol impacts the date attractiveness. All right, let's go ahead and look at graphs of this as well. Let's see if we can see something that kind of correlates with this. And that's exactly what we see, right? Looks like these two seem to be the same, but there seems to be a difference when we get to 4 pints. So it seems like a person's willing to accept a less attractive date after 4 pints. So we can say there was a significant main effect of the amount of alcohol on the attractiveness of the date. All right. Now the last piece that we want to look at is the interaction effect. So now we want to look at the interaction effect of the gender by alcohol. So the main effect of the interaction is significant. So the effect on alcohol on date selection was different for male participants than it was for female participants. So the interaction does matter. So let's look at a graph of the interaction. So it looks like for females are in the red, alcohol had very little effect. But for males, there's a small effect between no pints and 2 pints. But it started to rapidly decline when they got up to 4 pints. So we could say there was a significant interaction effect between the amount of alcohol consumed and the gender of the person selecting an attractive date. So that is an interesting interpretation. Well, the interpretation is correct. The result of the test is interesting. All right, so let's go look at our contrast. So the first one is no alcohol compared to 2 and 4 pints. And the second one is 2 versus 4 pints. So we can see that there is a significant difference between no alcohol, and 2 and 4 pints. And again, there's also a significant difference between 2 and 4 pints. so overall, we do have that significant value. And there we have our partial eta value as well, 0.489. All right, our post hoc test, trying to drill it down a little bit more. We can see if we're going to look at the bone Ferroni, no pines versus 4 pines, there is a significant difference. No pines versus 2 pines, there's no significant difference. 2 pines versus 4 pines, there is a significant difference. All right, and we kind of already saw that previously. All right, so what is this interaction? And how do we really know if there is an interaction or not? First of all, we have significant interactions, our non-parallel lines. So when we looked at that previous interaction, we did not have parallel lines for the males and the females. Obviously, it doesn't automatically mean the interaction is significant because the significant depends upon how non-parallel the lines are. However, if the lines cross, they're not parallel, which means there's probably an interaction that's may significant, but it may not always be true, so that's why it's always nice you have to run, in this case, the statistical test. This is comparison to like the ANCOVA, which we talked about. You don't have to run the test, you can just look at the lines. This is a little bit different because there's a level of significance. The homogeneous invariance is just an assumption. We want to know definitely whether or not this is significant. So in this case, we do have to run the test to find out whether there's an interaction. But if the lines cross, you're probably going to be guaranteed that there's some type of significant reaction. So is there likely to be a significant reaction for this graph here? No, probably not. This one here, yes, there's probably some type of an interaction going on here. But statistically, we need to be able to figure that out. Now, we could also just look, instead of looking at the line charts, we could look at the bar charts as well. So is there likely to be a significant interaction? These are pretty far apart, so the answer here is probably not. And here, the alcohol consumption, there might be. Everything's kind of pretty tight, so we might end up having some type of an interaction here. All right, the effect size. Again, we're going to go ahead and use the omega squared, but you have to get your standard deviations variances first. And then we end up with our omega squared, so we can say the effect of alcohol was somewhat of a medium effect. The effect of gender was no effect, and the effect of alcohol by gender was somewhat of a medium effect. So alcohol is most important here, right? There's my star. And alcohol by gender would be second, and gender itself just doesn't matter. So there's no practical difference when we talk about gender. It's the alcohol and the alcohol interaction with the gender. And that's pretty much it for factorial ANOVA. It's pretty cakewalk. The analysis takes a little bit more time, but it's really not as complicated as some of the other